Let's think. Oh, there we go. Okay, so recording. All right, so we are going to be kind of talking about how ionic naming and covalent naming kind of get put together today. Okay, so that's going to be that has been the biggest problem historically. Is not so much here's a bunch of ionic compounds, name them, or here's a bunch of covalent compounds, name them. It's here's a bunch of compounds, and figure out if they're covalent or ionic, and then name them appropriately. So that's the thing that people have the biggest problems with. So we are going to do that. Now I am going to present my screen. I'm not really sure how this recording is going to handle that. I don't know if it's going to record my screen that's being presented or if it's just going to record the Google Meet. If it just records the Google Meet, then this was a big waste of time. Recording, that is. But I don't know. We'll see. Okay. So we are going to do several of these problems. So first one we have is ZnSO4. Now, when you are not sure if you're naming a covalent or ionic compound, that is the very first step you have to take, is identifying it. Okay, the way that we identify if it's a covalent or ionic compound is by looking at the very first part. So the Zn right here. Okay, is that first part a metal or a non-metal? So to figure that out, we look at our periodic table. So periodic table, we're looking for Zn. Zn is right here. So it's zinc. It is on the left of the staircase, so that means it is a metal. Now, since it is a metal, that means this is a ionic compound. Okay. So next thing we have to do is identify if this needs Roman numerals. Since it's an ionic compound, we have to identify if it needs Roman numerals or not. Okay. So to do that, we look at our charge chart. Okay. And we look at this chart right here, the variable charge ions. If zinc is in this, we do need Roman numerals. If zinc is not in this, we do not need Roman numerals. And zinc, in fact, is not in this. So we do not need Roman numerals. We don't have to worry about charges. All we got to do is name zinc, which we did already, and then name the second part of the compound, which in this case is SO4. Now, since this compound has 3 capital letters, that means there is a polyatomic ion in here somewhere. And the polyatomic ion is the SO4. So we look at the charge chart. We find SO4, which is right here. Okay, that is sulfate, and it does have a charge of -2, which actually doesn't matter in this case, but it is sulfate. So we are going to name zinc just normally. Okay, it doesn't need Roman numerals like we established. And then we are going to name the second part sulfate. That's a really bad A, sorry. There we go. That's totally better. So notice I did not replace the ending with IDE. Okay, because this is a polyatomic ion, and with polyatomic ions, whatever it says in the charge chart, that is what you leave it as. You do not replace the ending of polyatomic ions with IDE. You only do that with elements. Okay? Okay, so moving on. Also, don't worry about this type 1, type 2, type 3. We are now worried about that. Okay, so next is COCl2. So again, we identify if it's ionic or covalent by looking at the first part. CO is the first part, so we look at the periodic table. We find CO, it's right there. It's called cobalt, and it is on the left of the staircase, which means it is a metal, which means this compound is ionic. So next step is looking at our charge chart, seeing if cobalt is in the variable charge ions, which it is. It's right here. So that means we do need Roman numerals this time. So we're going to identify the second part, Cl. Cl is chlorine, which, since this is an element, we are going to replace the ending with IDE. So it's going to be chloride. And it is -1. Now, since there are 2 chlorides, that means we have a total negative charge of -2, which means we need a positive charge of +2 to balance that out. So since this cobalt must have a positive 2 charge to balance out the negative 2 charge, that means we need a uh, Roman numeral 2 after the CO, or after the cobalt. So that's going to be cobalt, Roman numeral 2, because it has a charge of 2, chloride. Okay? All right, moving along. CCl4. Okay, so again, first step, ionic or covalent. Okay, we look at the first part, which is C. So we go and find C. C is carbon. Now, this time, the first thing is an null. So that means we are dealing with a covalent compound this time. Second part is Cl, which is still chlorine, which we're going to change to chloride. Okay. Now, since this is a covalent compound, that means we need to use our prefixes, which again are on the charge chart. They are right here. So carbon, there's one of, so that's mono. Chloride, there's 4 of, so that's tetra. Okay. So we would say monocarbon tetrachloride, but remember, when we have one element for the first part, we just drop the mono. We don't use it. Okay. If there were 2 carbons, we would say dicarbon, but since there's only one, we just drop that and we call this carbon. Whoop, I forgot the R. Spelling is hard. Carbon tetrachloride. Okay, and that's all you have to do for covalent compounds. Just match those subscripts with the prefixes and then put the prefixes in unless there's a mono for the first one. Okay. Oh, and I forgot the E. Man, spelling is super hard for me today. Okay. Next, we're going to do this one here, NiOH2. Okay. Now, notice there are 3 capital letters, which means there is going to be a polyatomic ion. Also, this one's nice and easy because the polyatomic ion is in parentheses, so it's going to be easy to identify. So, rewind a second. First thing we have to do is identify ionic or covalent. So, Ni is right here. That is a metal, which means this is ionic. So, next step, we look to see if Ni is in the variable charge chart, which it is. Ni right there. So we do need Roman numerals. Okay. So we got to figure out what our charge is of Ni. So to do that, we have to figure out our charge of OH. OH is a polyatomic ion. So we have to find it on the charge chart. It is right here. It is called hydroxide and it has a charge of -1. Now, since we have 2 of them, we have a total negative charge of -2, which means we need a total positive charge of +2. So that means nickel is going to have a charge of +2, which means its Roman numeral is going to be 2. And then we just name our polyatomic ion as such, nickel 2 hydroxide. Okay. Okay, we're going to skip down a little bit. We're going to go to this one right here, ClO2. Okay, now ClO2, if you just look at it at face value, it's a pretty easy one. But the thing is, ClO2 is very similar to, where is it? There it is. This polyatomic ion, right? So this polyatomic ion says it's called a chlorite. Okay, so we just named this chlorite, right? Not quite, because here's the thing. This is ClO2. This polyatomic ion is ClO2 -1. Okay, now that -1 is very, very important. That changes the whole chemical structure of the compound. Okay, so that means that ClO2 -1 is not the same as just regular old ClO2. So just regular old ClO2 is not chlorite. We still have to name it appropriately, just like all the other stuff. Okay, so our first step is to identify ionic or covalent. Cl, we've identified that already. So that's chlorine. That is a nonmetal. It's right here. So that means this is a covalent compound. So we look at our charge chart, look at our prefixes. There is one chlorine, which is mono, but since it's at the beginning, we drop the mono. There are two, I forgot what the other thing is, oxygens. There are two oxygens, so that means we use di. So our name is going to be chlorine dioxide because we replace the ending with IDE since this is just an element. Okay. Okay, we're going to do one more, and then I'm going to give you guys some time to practice. We're going to skip down here to this one. Okay, Fe2SO4 3. So first step, ionic or covalent. Fe is iron right here. That is a metal, which means this is ionic. So we have to check our charge chart. Is iron in the variable charge ions? Yes, it is. It's right here. So that means we need Roman numerals. Now, SO4, that is a polyatomic ion. So we got to look that up. SO4 is right here. That is sulfate, and it has a charge of -2. Now, there are 3 of them. So that means our overall charge is -6 because it has a -2 charge and there are 3 of them. So 2 times 3 is 6. That means we have to have a positive charge of +6. Okay. Now, this is another place where people mess up a lot. Okay. Our Roman numeral for iron is not going to be 6 because the Roman numerals represent what the charge of each individual ion of the metal is. Since we have 2 iron ions and they add up to have a charge of +6, each individual iron ion has a charge of +3. So that means our Roman numeral is going to be 3. So it's going to be iron 3 sulfate. Just like that. And I'm going to end the recording here.